everyone. So this lesson we are focusing on finding the sum of an infinite geometric sequence. So let's look at the diagram here. This diagram represents a wall, and imagine that you're 2 meters away from a wall. So therefore at the first step you're actually moving 1 meter towards the wall. So this wall is actually so standing here, from here up to the wall the distance is 2 meter, and imagine you're trying to move towards the wall. So the first step you're trying to move 1 meter, and in the second step you try to move half a meter, and then in the third step you try to move 1/4 of it. So each time when you move towards the wall you're actually covering half of the previous distance. So let's actually write this as a geometric sequence. So therefore the first term is 1 because you're covering 1 meter. You're just moving 1 meter. Second term is half because you're just moving half of the distance of the previous step. Third is 1/4, and fourth term is 1/8, and so on. So this is representing an infinite geometric sequence. So therefore we need to find the sum of the sequence in here. So let's actually use the formula to find the sum. So here a is equal to 1 and r is equal to half. So the formula used is Sn is equal to, when r value is between -1 and 1, use the formula a times of 1 minus r to the power of n divided by 1 minus r. So therefore we will actually write a as 1 times of 1 minus, so half can be written as 0.5 to the power of n divided by 1 minus of 0.5. So again in the next step we can write this as 1 minus of 0.5 to the power of n divided by 0.5. So Sn is equal to, this is actually the general form we are getting. So therefore we can also simplify this as 1 divided by 0.5 is 2. So 2 minus of 0.5 to the power of n minus 1. I'm just splitting it as two different terms with the denominator, and so I get the general expression as Sn is equal to 2 minus 0.5 to the power of n minus 1. So let's look at the term on the right hand side, which is 0.5 to the power of n minus 1. So let's actually sub in, when n is equal to 10, 0.5 to the power of n minus 1 is equal to 0.5 to the power of 9. That gives you 0.00. Just use a calculator and you get 0.00195. And then let's actually again increase the n value. So when n is equal to 20, that means it is 0.5 to the power of 19 is equal to 0.0000019. So therefore what do we actually observe in this step? We can see that as n approaches infinity, 0.5 to the power of n minus 1 approaches 0. So as n value is increasing, this term 0.5 to the power of n minus 1 approaches 0. So therefore what we actually find from the previous step, Sn is equal to 2 minus 0. So Sn is equal to 2. So what do we understand from this? So therefore when we look into the diagram, we actually see that the total distance is 2 meter. When we actually represent this as a geometric sequence, we can actually see that the common ratio lies between -1 and 1, and therefore we can actually see it's possible for us, even though it's an infinite geometric sequence, we can actually find the sum of this infinite geometric sequence that equals 2. So therefore, whenever we have a geometric sequence where the r values between -1 and 1, that the sequence, it converges to a particular value. So therefore, when it converges, when the sequence is convergent, that means we can actually find the sum of this infinite geometric sequence, and that formula is S infinity is equal to A divided by 1 minus R, because the expression here in the formula 1 minus r to the power of n, it approaches 0, because as n value increases 1 minus r to the power of n, it approaches 0. So therefore, the sum of the infinite geometric sequence is equal to A divided by 1 minus r. So this is only possible when the r value is less than -1 and 1. Let's do an example where we apply this formula. So find the sum. And the sum to infinity of the GP 2, 0.4, 0.08, 0.016, and so on. So therefore, here we can actually see that the first term is 2, common ratio is 0.4 divided by 2, that gives you 0.2. So the r value lies between -1 and 1. So we can actually see that this infinite geometric sequence, it will converge to a particular value. So therefore, because it converges, we can actually find the sum of the infinite geometric sequence using this formula, A divided by 1 minus r. So which is equal to A value is 2, R is 0.2, that gives you 0.8. So 2 divided by 0.8, that gives you 2.5. So therefore, the sum of the infinity of the given sequence is equal to 2.5, which means when you actually add up the sequence, altogether the sum of this infinite geometric sequence gives you the value 2.5. So this is only possible when the r value is between -1 and 1, where the sequence converges. But if the r value is greater than 1, which means the geometric sequence, infinite geometric sequence, it diverges, which means it increases. So therefore, we can only apply the sum of infinity of the sequence formula when the r value, when the common ratio is between -1 and 1. Let's look at another example. So here the sum of infinity is already given to you. The sum to infinity of the geometric sequence, I'll just write it as geometric progression in short. So sum of infinity is 6.25 and the value of r is 0.2. So find the first 4 terms of the sequence. So what do you find? So therefore, first we will write the sum of infinity is given as 6.25. So r value is given as 0.2. So in order to find the first 4 terms, we need to know what is A. So here it already says, because r value is between -1 and 1, you can use the sum of infinity formula, which is A divided by 1 minus r. Sub in the value of S sum of infinity, which is 6.25. which is equal to a divided by 1 minus 0.2. So just we need to first find the value of a. So 6.25 is equal to a divided by 0.8. So a is equal to cross multiply 6.25 times it by 0.8, which will give you a calculator that gives you the first term, which is 5. Next we can find the first 4 terms. So the first term is 5. So we know that the common ratio is 0.2. Multiply 5 times 0.2, that gives you 1. Third term 1 times 0.2 is 0.2. Fourth term 0.2 times 0.2 gives you 0.04. So now we have, so in this question, sum of infinity value is already given, and then the value of r is given. In order to find the first 4 terms of the sequence, you just have to use the formula, substitute the value of sum of infinity and the r value, and then you can find the first term value a, which is 5. Then you can generate the sequence.